Okay, everybody see the projector?
Yes.
Yeah, yes.
Yes.
Okay, good.
And we hear you.
All right, so the topic is the ESP32 E4 compiled by C. And I just want to go, let me see. Okay, so the summary of the subject is from Harvard to Princeton about the architectures of the computer languages. And I talk about the macro assemblers written in C, which built the ESP32 E4. So there's start with a primitive assembler and write macros to build a bytecode, to assemble bytecode, and macros to assemble colon words, and then build the structures inside the colon words. And the level 4 is, of course, ESP32 E4 itself. C, as most other languages, assumes a Harvard architecture with separated code and memory spaces, separated code and data memories. But on the other hand, the FORTH assumes a Princeton architecture with a unified code and data memory. And with this Harvard architecture, C as a compiler is very limited. C cannot compile variable length bytes and word structures. But FORTH must have a dictionary with extensible variable length fields. And with that requirement, C as a vanilla C compiler cannot compile FORTH. But C at runtime can produce very complicated data structures, including a FORTH system. So we can build in C a FORTH kernel of bytecode and a FORTH byte assembler, and many macros which can assemble FORTH words and build the complete FORTH dictionary. So ESP32 E4 actually it emulates EP32, which was a 32-bit FORTH microprocessor designed according to the architecture laid out by Chuck Moore. And ESP32 is a universal byte machine, which executes bytecode sequences stored in a memory. So here is the byte engine, one line of code in C. So it just picks up the next byte in this data memory, in this dictionary, and then execute that bytecode from this primitive code table. So the level 1 assembler, if I want to compile a FORTH system, the minimum is something that can compile bytes and words. So in the C code, I open up a big array for dictionary. The C data is a byte array, and the data is the same array, but organized in words. And the pointer P is a byte pointer, and pointer IP is a word pointer. P and IP are always related by a factor of 4. So here is the byte assembler. This is a level 1 assembler. So with this C code, you can assemble, you can add 1 byte to the dictionary. And with this 1 line of code, you can add 1 word to the dictionary. So C data and the data are the same array, but with organized in bytes or in words. But you just have to access them with different pointers. So once you have that level 1 assembler to assemble byte or word, then you can build a much more sophisticated assembler by giving each byte a name and have a macro header, which can assemble a header in the dictionary, and a macro code, which can assemble a sequence of bytecode into the FORTH dictionary, and thus build a primitive code, because this engine executes only bytecode. The level 3 assembler, which I call the macro assembler, and you can FORTH words are given names, and the macro colon would assemble words into a dictionary to build new FORTH words. And for the forward or backward references, you need a label to mark word sequences so that you can refer them later. It's kind of awkward to use label to do the assembly because it requires 2 passes. You have to do the first pass, locate all the words, and in the second pass, you would be able to have the correct addresses to compile them. So to to get around that, I created more macros, which does the structure. So I have if, which is a macro, and which will assemble the true clause, and else would assemble the false clause, and then would terminate this if else then structure. And so it's for next for loops, and then begin until again while repeat for indefinite loops. And these macros allow me to assemble structures in FORTH words. So this way, I can build the entire FORTH system inside C using a C compiler. So ESP32 E4 .ino is a single file of C code, which is compiled by Arduino to generate a working FORTH system on an ESP32 kit. And it allows me to access all the ESP.io devices and all its facilities, all the C callable routines, including Wi-Fi, which we hope to use to control the AI robot. Okay, in conclusion, C is a universal assembly language, according to Will Baden. C cannot compile complicated structures, but in runtime, C can generate very complicated systems, even like ESP4. Hence, we bridge from the Harvard architecture to the Princeton architecture. Thank you very much. Any questions?
Wonderful, Dr. Ting.
Let me try to.
Dr. Ting, this is Greg. Can I ask a dumb question, please, sir? When you talk about the Princeton and the Harvard architecture, how would you describe the 2 differences between the 2?
It's let me see, let me just cut off my screen, if I may. You are still sharing. Okay, stop sharing. Okay. Okay. All right. The Harvard architecture is all the computers first designed in the 40s. Okay. Having program memory and the computation memory or I/O memory implemented in different manners. Okay. And in the Harvard architecture designed in Harvard, the memory is still, the program memory is on paper tape.
Okay.
And so the, let me see, in the, I cannot remember all the code name. In some other machines, the memory is, some computation memory is in vacuum tube, and some memory is on disk on magnetic materials. So they are all organized differently.
Mercury also, Dr. Ting. In Mercury drums, no?
Okay. Yeah, but when the von Neumann visited Pennsylvania State and look at the electronic computer they built there, and he immediately felt the computers should not be designed that way, because program memory and the data memory does not have to be different. They can be the same. And so he went back to Princeton and wrote a report and proposing what he called the von Neumann architecture, in which the memory, the program memory and the data memory are the same, are in the same electronic memory. And so this greatly simplifies the computer architecture, and it was mostly followed by later computer designs. So that's what the Harvard architecture and the Princeton architecture are named.
Thank you, sir.
Excuse me. Okay, I think this is only a very brief summary of what my thought process in building the FORTH system. Actually, every FORTH system are built basically that way, you know, from the very basic comma and C comma, and you build the entire FORTH system, and it just depends upon how sophisticated you want and how easy you want to control and carry out the building of the very complicated FORTH dictionary.
Thank you, sir.
I have one comment. I'd like to see Brad do a talk of the C extensions that he did to Dr. Ting's eforth, C and eforth. And there was a question earlier about pulling in other C code and creating words. And I know that it has the capability of doing that. So that would be pretty cool.
In dealing with the ESP32, this kit, this computer is not a, it's a beast. It's very complicated. And the CPU, there's no access to the CPU. So, you know, the only way I can get a handle of it is through the C compiler. But the advantage is that there's a ton of code already being developed with this system. So all you have to do is calling the C routine. So if I have a system programmed in C, I can call all these utilities directly, and that makes the Wi-Fi. I cannot program the Wi-Fi. I don't even know where to start. Okay, but in ESP32, you are given the library, the Wi-Fi library, and you can tailor the command to your need. So this is what I think that's the only way we can use ESP32. You cannot bypass the underlying the compiler or the OS.
I think that's a huge feature, and it would be good if you could expand upon that in future talks.
Ask questions.
Yeah, are there any more questions?
Guys, yes. More questions, Ulrich?
No, I'm happy.
Okay,
I've got a
because we
question.
are very short on time, everybody extended.
I have one question, maybe.
Yeah, Thomas?
Yeah, Dr.Ting, very nice talk. And I started FORTH some 30 years ago, but now I switched also to Python. What do you think of quantum computing? Do we have a chance to do FORTH on quantum computing? Because when I was at a CeBIT 2 years ago in Hanover, the central fair, you know, CeBIT, one of the world's greatest fair, there was the IBM quantum computer, and they showed some Python libraries or Python interfaces, so you can program their computer with Python. Do you think this will be possible also with FORTH?
Yeah, you know, in the Silicon FORTH meetings, Silicon Valley FORTH interest group meetings, we have a fellow who's talking about quantum computing many times, but I just couldn't understand anything he's talking. I don't understand the quantum computer at all, and I just don't understand how it can possibly work. Okay, and but you know, all these big companies are behind it, IBM, Google, and everybody. So it must be real.
Yeah.
But I don't understand it.
And of course, you can use FORTH as an interface language to whatever machinery is behind that. I don't see why Python has any advantage. On that
Ulrich,
side.
what you're saying is very interesting. We got another German, very clever guy, the Bernd Ullmann. He works with analog computers, and he did a wonderful presentation. I invited him today, but he's probably making an analog something with his he lives inside the computer. He's very busy every day, and he used FORTH, camel FORTH, in a card to interface to his analog computer.
Yeah, right.
Mm-hmm.
Are there any additional questions?
Yes.
Yeah, I wanted to ask one. Dr. Ting, what is the difference, or how does eforth differ from ANS FORTH? I'm new to FORTH, so I don't know.
That's a very serious problem. Okay, I think Don and Don's talking about the running FORTH tutorials use starting forth. Use starting forth as the basis of tutorial. And of course, starting forth seems to be the best book on forth. But I'm very, very concerned because the ESP4, ESP E4 or eforth in general is not compatible with NC4. Everything else are pretty much the same except the loops. Okay, the loops, the do loop is the standard fourth loop, and in eforth we use the for next loop. And I'm hesitating to expand eforth to include do loop because you know, do loop is obsolete. The reason why Chuck Moore wrote the forth with do loop was that he's tried to emulate Fortran loops. So if you look at the fourth loop command structure, it basically does what Fortran do loop do, okay? And I think a number of years ago, Chuck Moore actually apologized that he designed the do loop in the beginning. And his thinking is that the for next is a much more efficient way to
Dr. Ting, I have the sources of the do loop extension for eforth, so I can share with our friends on the Facebook page. I will do that.
Yes, yes, I think please do. Please do. I think you fourth. I'm just waiting for somebody to volunteer to
I got it. I got it.
To put do loop. Okay. Yeah. But I will not do it.
And the for
I will not do it because this is philosophically against my guts. Okay, because do loop is complicated, and it cannot be mechanized. Okay, so when Chuck designed the P series of processor, he just used the for next, because the for next, the next command can be condensed into a single instruction. And in the EP series of processor, the next is a single instruction, and it executes in a single cycle. Do loop cannot do that. Do loop requires two parameters. With two parameters on the stack, you have to do lots of jugglings on the loop indexes to get the loop to work. So it is very inefficient. And if you look at the next instruction, it is a single. If you design the CPU correctly with the data stack and the return stack all in the CPU, then next can be a single cycle instruction. So you can actually in a single cycle, you can keep the loop going with the minimum overhead. So with that advantage, I'm not going to implement do loop in my eforth. But your eforth that's yours, okay? And I'll be glad to see that somebody does it. And because if Don's going to run his his tutorial based on starting forth, he will need do loop. So.
Okay, thank you very much. We can elaborate on that later on. Thank you very much. A very nice talk, and I appreciate your opinion on do loop and for next. And so we are having our salutations, and Ilya is probably well known to the group, but I didn't know he missed his salutation. So Ilya, are you prepared to talk about